Hey again guys, and welcome back. Today I want to take a look at this MotoMaster Eliminator booster pack. This is one of these little lithium dillies. At least I think it is one of these lithium dillies. I hope it's one of these lithium dillies. Let's just put it that way. This thing is not working. In fact, let me show you what it does. So you can turn it on like so, and the battery will show 25%. It'll flash and then it'll turn off. I can also show you that these crocodile clips here on both sides, they're supposed to boost your vehicle, but if I check the voltage on them, they have 500 millivolts on them. So that's not enough, and even if you turn it on and then you go to manual override, it still only gives you a couple of millivolts. Yeah, 500 millivolts. You can't even override them. And as far as I knew, these things were supposed to be on at all times. No, it's through a MOSFET, I guess. But see, I can't get it to go. There's an LED flashlight that turns on just ever so briefly, and it just dies. Okay, this thing is cooked. That's why it was given to me. And also, USB in, if I use my beautiful pluggable dock here, I plug in a charger adapter, you'll see we have 5 volts, or maybe you won't see. There we go. 5 volts, 0 amps. I plug it into here. The USB in is a micro USB, and I've tried with all sorts of charging cables. And this light will come on, show the 25, and it'll flash as if it's charging. But if you can see here, it's using 0 amps. If I turn on the flashlight, it'll use 380 milliamps. Let that cycle through. Yeah, 360 milliamps. I've had this plugged in for a whole day and nothing. So this thing is dead. Now, this could be a repair mission, but I think more likely is that it's going to be a salvage mission. The inside of these things are giant lithium pouch cells, usually. So if that's the case, I want to salvage the lithium pouch cells. Now I've already started taking this apart, simply because I wanted a dry run. So I took these little cheeks off, like so, flipped it around, found that there was 2 screws here and here, which I then took out with this triangle drive screwdriver I had to order for this. Now it's still not coming apart because I think there are more screws underneath this sticker, like there. Yeah, I think that's a hole there. So I'm going to try to peel the sticker. Don't feel bad for this device, because if this is actually a coworker that gave it to me, and if I didn't take it, it was going to be, well, I guess recycled, I guess. Yeah, it does say 56 watt-hour lithium-ion, so I don't think there are 2 sealed lead-acid batteries in there. If there's cylindrical cells in here, I will be absolutely thrilled. So there's a screw hole. Take this one out. But if there isn't, and if the cells are dead and it's not the circuitry, then we've got some nice alligator clips. We've got some thick 6 American wire gauge wire that we can salvage. We have some USB ports. We have some charging circuitry. We have all sorts of stuff. I think I'm just going to peel this completely off, because even if I can repair it, I don't think I care about keeping the labeling intact. So I'm just going to take these screws off. It seems to be 4 screws, and I'll bring you right back. Okay, all the screws are out. I'm bringing you back for the big reveal. This is actually IP65. Yeah, IP65, so it's waterproof to a certain amount. Here it comes. Oh, wow. Okay. Big lithium pouch cell. That is interesting. And here is the... So this is like an RC pouch cell. I don't think it's puffy. Okay, we got to be careful here because this potentially has a lot of juice still in it. So here is the actual battery connection here. So let's probe this. So this is that's a 3-cell battery. So this here is the potential. Like, I've been shopping for lithium batteries. This has the potential to be worth quite a bit of money. 8.5 volts, 8.5 divided by 3. Ooh, we're a bit low on voltage. I'm going to check all the cells. So let's see. Don't want to short these. Yeah, maybe I'll just do this. I'll unplug it first. Let's be smart about this. Just because I'm excited doesn't mean that we should throw caution to the wind here. Got another 2 here. NTC. Oh, there's a thermistor. Temperature. Okay, so that's off like that. There's a rubber gasket. Very nice. Relay. So yeah, there's a relay board here. 2 big chunky. These are like the GM style relays. I'm going to get these free in just a moment. Oh, the big bus bar going to one side of these batteries. This may not be that simple. Ugh, it's making noise and scaring me. This may not be that simple of a teardown. Okay, got the gasket out of the way. Got some LEDs here. Nice inductor. We've got the USB in and USB out on this side. We'll have to look at what's the circuitry looking like on that side, but first let's see if this thing is salvageable. So let's see here. Looks like this will all, yeah, this does all come off. Sweet. Yeah, this is no joke. Yeah. There we go, NOCO Lithium E19. 11.1 volt battery, 56 watt hours. So these have giant bus bars. Look at that soldering. They got this like red hot. They've got these 2 honkin' relays there, probably in parallel. And this must be the diodes to prevent to prevent reverse polarity. So this is that. So that's interesting. Even if this thing is toast, we still have a good set of diodes in here, possibly. Alright, let's check the voltage across these bus bars. Yeah, 8.51 volts. Very interesting so far. So we have an average of 2.83 volts per cell, and that's not necessarily good. Typically you want to bring your batteries down to 3 volts and no lower, although the manufacturers will tell you it's okay to go lower. It's just not good practice. So let's see here if we can probe between this yellow here and our ground. That's a single cell. Uh-oh, that's bad. We have a single cell at 4.26 volts. Let's probe between the yellow and this white. I'm going to have to be very careful here. Am I in shot at least if there's sparks that fly? Ooh, I don't know if that cell is any good. I will probe between the white and the red. 4.2. We have one completely dead cell in this battery. That's what's happening. So measuring between the red and the white, that's cell 1. Between the black and the yellow, that's cell 3. Though that means that cell 2 here has no voltage left. We have a single dead cell, and that's unfortunate because this is still usable, but we're gonna have to do surgery if we want to use it. We're gonna have to open this pack up and remove the dead middle cell, and then we can have 2 fairly good pouch cells, but not the 3 I was expecting. So that's not too bad, actually. I'll do this pouch cell recovery in a different video, but yeah, this is dangerous here because this bus bar is live, and so is this positive terminal. So if this positive terminal goes and touches this bus bar, it will dump all of its current through these massive 6-gauge wires, and possibly send molten metal flying my way, or just even puff the batteries. If it's a continued thing, the battery could blow from the overheat. So we got to be very careful. I'm actually going to go get some tape and tape up these connections so that they never touch. Now that we know for a fact that this can't be saved, there's nothing you can do to a dead cell to make it reliable. We might try to revive it, but that's a different story altogether. Let's go into salvage mode. Either way, this pack will never be the same again. So let me grab a screwdriver and we'll start salvaging some parts. I have to say, these things are very expensive here in Canada, like this brand specifically. And I think it's because the brand, well, not the MotoMaster, sorry, the company who makes it for MotoMaster, I think they're the same ones who make the Genius brand stuff, but they seem to make, I think Norco is the company, they seem to make their own components and everything, so everything seems a little bit more expensive. It's quite a shame if you got a cell that breaks down like that. Here we go. This is our circuit. We've got a Holtec chip here. I guess that is doing most of the work on this thing. We got this interesting daughter board, 2 daughter boards, one with the USB out and one with the USB in. So that's going to be an easy salvage. I'm just going to heat those up and pull it out. It's just power delivery too. There's only 2 connections, one on this side and one on the other side. So that's good. We've got a nice, I will say that's a choke, because usually when it's 2 different wires wound around the same one, it's like a common mode rejection choke. We've got another one here, smaller one. Got a couple caps. Got a LED board here. Moderately bright LEDs, but not that bright. And there seems to be 3 connections, 6 in total. I'm guessing they're in parallel. Here are some capacitors. So they put capacitors on the back of these LEDs to stop the PWM sort of flash, which is pretty crazy. Like it's pretty interesting that they went through that much effort. So this thing, there's a reason why it's expensive. We also have this lens assembly here. Is that glued in? That's actually glued in. Wow. So if I want that, I'm gonna have to try to prise it apart a lot harder than that. This plastic is extremely stiff as well. It's pretty incredible. I'm no AVE, so I couldn't tell you exactly what kind of plastic it is, but I can find the other part. No recycling markings on this part either. Let's see if we can do the AVE test to hear if there's glass fibers. Wow, there is. Listen. Oh, I don't want to cut myself. You hear that? The little scrunchiness? So this is some sort of, poly material with glass fiber. Very interesting. I don't see anywhere for them to put the marks though. They really should. On here, it looks like we have two opto-isolators, there and there. I can tell by the package shape. If Google Gang wants to look it up, they are Cosmo 1010817812. We've got a chip up here, very likely for the balancing of the lithium batteries and for the checking of the voltage on each cell, because it goes up to this bat connector, and we see the NTC goes directly over to the microchip, so that's being dealt with directly. This section here will be your 5-volt delivery, because that's where the USB delivery is. This guy here, you see these two inductors here, two big diodes here, so this should be capable of delivering a decent amount of current. The relay connector being here, with the traces going to this transistor, and this transistor has a trace. It has a trace heading to the microcontroller, so it's probably microcontroller triggered. You've got a couple switches, these switches here, which are these little levers that are actually cut into the case, and they look like they are checked by the micro. Couple of 8-pin devices here. Taking a look, one is an LM358, this one here, so that is an op-amp if I'm not mistaken, so it must be amplifying the signal from something like maybe the NTC or something like that. Above it is a ME4435, actually two of them, and they're labeled Q. I'm not quite sure what they are doing. Then over here we have BVG700. That must be the balancing monitor. Got a couple surface mount LEDs. And our main power chip here for the 5 volts is a MP1584EN. So yeah, unfortunately, I'm not that well versed at reverse engineering circuits like Big Clive would be, and these traces would take me a long time to take a look at, but I don't see any hotspots. I don't think that this is the problem that ruined the lithium cell. I think just the cells were not matched very well. One wore quicker than the others, and this board did its job and it refused to charge it up because of that. So yeah, I'm going to do some experiments with that lithium-ion cell very shortly. If you're interested in seeing that, make sure you are subscribed. But for now, this thing is going in the salvage pile. Thanks for watching.